So as we take this panel here, our esteemed panelists will discuss the current status of Indian tenders, the key steps to ensure viable project outcomes, and then the strategies to overcome implementation challenges.
Looks like we have a line through now. Thank you everyone for joining us today for this session on offshore wind. And the session is titled At the Cusp of Creating a New Value Chain. And I think that, just by way of background, I've been in the wind industry for 20 years now, and the last 10 years, or last 7 years in my career with the turbine manufacturers was in the offshore space. And back in 2014, I remember meeting an Indian delegation to talk about offshore wind in India, and I think that it's actually looking to be, we're actually getting there, and I feel like there's actually a lot of momentum actually happening here in market. I just wanted, before we actually, I hand over to Dr. Katyal for his presentation, I would just like to say, in terms of the global market, it's a really interesting picture. I mean, we have installed a total of around 75 gigawatts so far in the first 30 years in offshore wind, and we're accelerating year on year. Last year we installed 11 gigawatts, and a lot of that was installed in China and Europe. There was only a couple of markets outside of those two countries that are actually installing wind at the moment. So for all of the hype and all of the talk in all of the other markets around the world, there's still a lot of work to be done. And so even countries like America, where there's a big pipeline of offshore wind projects, actually there's still a lot of work to be done in the offshore wind space. So it's great to be here in India, and it's great to be here to be able to speak with fellow panelists and to moderate a session that is going to look at some of the challenges and opportunities that we see here for the Indian market and what that means for all of us in the room, and also the global offshore wind ecosystem. So, Mr. Katyal, please, the floor is yours.
Distinguished panelists on the dais and dignitaries of the dais, all of you are aware that National Institute of Wind Energy is one of the technical arms of the Ministry of New and Renewable Energy, Government of India. And we look at our role as one of the facilitators for healthy and orderly growth of wind energy sector in the country, comprising of both onshore and offshore applications. And in the presentation area today, I will be discussing very briefly on the pre-project activities which National Institute of Wind Energy has carried out for fostering the growth of offshore wind in the country, just to set the tone, because I do believe there are so many international delegates on the dais, and all the audience will love to listen the healthy and orderly discussions and the questions for them. So I will be very brief and crisp to set the tone. And all of you are also aware, needless to mention, that in India, we have a long coastline of about 7,600 kilometers, and out of which Gujarat has the longest with 1,600 kilometers length, and Tamil Nadu, of course, is 1,076 kilometers. And the preliminary resource assessment which various organizations, including NIWE, has carried out, has clearly indicated that Tamil Nadu has the best potential, which is falling under the class 1 category as per the IEC standard. The western coast, Gujarat, comes under the category of class 3 wind speeds, and we have a potential of about 70 gigawatt, which needs to be rechecked by a fresh long-term measurements. And for the benefit of the members and also for the international audience, that Solar Energy Corporation of India, which is one of our sister organizations under ministry, has already come up with a tender at Gujarat. You can see on the presentation the red circle, which is the earmarked area where NIWE has already carried out the pre-project studies and surveys, whether it is wind speeds, the directions, or the met ocean and other oceanographic parameters. And out of this 375 square kilometer, we have chosen the best 202 square kilometer area, where we feel that the first 500 offshore projects supported by viability gap funding can be taken up. And why we have chosen this? Because we found, as per the forward study, that this has good speeds to the range of about 7.8 to 8 meters per second. And also, all the other pre-project activities, studies have already been carried out by NIWE, and which is bare minimum required for participating into the international competitive bidding, for which I have been informed that solar energy is in the final stages of settling down the pre-bid queries, and probably because in India the festive season is on after Diwali, probably they will try to finalize the pre-bid queries. And just to give you a glimpse, most of you can also go through the tender document which is available in the public domain. But just to give you a few highlights, that in this Solar Energy Corporation will be entering into the power purchase agreement for 25 years, and probably because of that they wanted to upload on the website. They have slightly deferred the pre-bid finalization after Diwali, and then the declared or the revised capacity utilization factors shall not be in no case less than 40%. And I'm very also happy to inform you that GUVNL, which is the Electricity Board Department in the state of Gujarat, has agreed as a special case to buy back the power at the rate of ₹4.50 per kilowatt hours. And Ministry has also been very, very flexible. Other than the viability gap funding support, they will be giving the bidders to avail all the physical incentives like accelerated depreciations, concessional customs, and excise duties and tax holidays, which is valid until December 2032. And the successive bidders will decide to go with the reverse bidding as per the auction which is available. All details are available in the tender document. So I will not go much details because all these tender documents are available in the public domain. And all of it I want to highlight is, you can see the blue portion is the 202 square kilometer area, and at the edge of this, the officers from, rather the CEO and the officers from Central Technical CTU, they have already awarded the work to the Power Grid Corporation of India, wherein, NIWE with the help of Danish Energy Authority has come up with a pre-feasibility report where we planned that the 2 into 315 MVA transformers will be installed and commissioned at the edge of the zone where we are planning to go for these offshore projects. And from there, about 30 kilometers, we will be injecting it to 400 bar 230 kV substation, which is at Mahua. And from there, they will be injecting finally at 190 kilometer at Vataman, which is 765 bar 400 bar 220 kV substation. So these details have already been worked out as a pre-feasibility report, and the developers will be developing the internal array cables, which we have tentatively planned as 300 square mm aluminum inductor cables, and also the 630 mm AI conductors. But the export cable, I guess, finally PGCIL and CTU will take a call, but it will be something higher than 1000 square mm AI conductors. All these detailed plannings have been carried out, and I think they are also working on the detailed project report, and they will be making the substations ready to the size of initial 500 megawatt both in Gujarat and Tamil Nadu, and also up to 5 gigawatt both in Gujarat and Tamil Nadu, so that the transmission utilities are readily available. And moving forward in Tamil Nadu, all of you are also aware, again, Solar Energy Corporation with active support of National Institute of Wind Energy has come up with the seabed leasing tender in the zones which you are seeing 2, 3, 4, 7, and which is also in the final stages of pre-bid settlements. And very recently, I am very happy to inform you that in the zone 1, the green color half portion, where we are planning to go with the floating buoy, which Mr. Bibhu Nayak is available. He is from Fugro, and I am not advocating on Fugro, but I am telling you a transparent and honest thing that in a record time of 5 months, National Institute of Wind Energy with their active support has deployed the floating buoy, which is available at zone 1 now. It was installed on 5th of October, and we have got about 10 days of data which is being pushed to the NIWE server through an Emersat, satellite-based system. So this data is very essential in the sense to plan and to take much more informed and better decisions to arrive at meaningful conclusions. So you can see this is the pictorial representation of the first kind of floating buoy which has been installed by the government agency with the government fundings. And this measurement was started, as I said, on 6th October. And I will also like to show you some of the graphs. And you can see the wind speed graphs. We have measured at 10 multiple levels, starting from 10 meters to 300 meters, but the point of our focus would be about 180 to 200 meters. And you can see the winds has gone high up to 12 to 14 at 300 meter levels, but definitely at 150 to 180, the turbine hub heights, you will be getting about 9.5 to 9.6 meters per second. These are the results for last 8 to 10 days. But when we go forward, we will be able to present you a larger picture when we have the good data sets. And similarly, the wind directions, basically they are westerly directions, whatever we have captured for 10 days, which would mean that winds are blowing in the western directions and the turbines have to be aligned perpendicular to west or southwest so as to capture the maximum power available in the wind. And these are the wave heights. We have also covered, apart from the wind speeds and direction, the Met Ocean parameters. And you can see this violet color at the top graph, which is a significant wave height, which would mean that about 80 to 70% to 80% time, the waves, water waves in this particular area for a 500 VGF project in Tamil Nadu is ranging from 1.5 to 1.2 meters. But 20% of the time in 10 days, it has gone up to 3 to 3.5 meters also. So in any way, this will give good input for designing the offshore substructures, which will be moving between 1.5 to 3.5 meters. And we have also captured the wave directions, the water waves, which is also showing the similar trend and a close match as the wind speeds, which is also from the westerly directions. You can see at the bottom graph. And similarly, we have also worked out on the water current speeds. And water current speeds at the mean sea levels is almost constant, but the water depths in this area where we are going to put up this 500 megawatt in Tamil Nadu will be about 30 to 40 meters. And at that level, we feel that the water currents are varying from 0.3 to 0.35 meters per second for the last 10 days. But I hope it can go up to 0.5 or 0.6 when the northeast monsoon begins with. And similarly, the water current directions are also a little bit dynamic. In last 10 days, you can see this blue graph, which has changed from 90 degrees to, it has gone up to 270 to 280 degrees in the westerly direction. And why I am showing you these graphs? Because this gives a confidence to the international players that we are doing as per the Carbon Trust guidelines, the measurement, and so that they can take much more informed decisions and they will be closer to the annual energy productions and the yield so that it can mitigate the risk of underperformance for their 25 years of design life of the offshore wind turbines. And apart from this, at Gulf of Mannar, to give you a confidence that we have also installed 3 more LIDARs for which we have been measuring the data for last 7 months. And you can see this has also shown a similar trend with 9.15 to 9.5 meters per second. And the winds normally starts picking up after 2 o'clock in the afternoon and goes up to 10 o'clock, which gives an indication that at the coastal belt, offshore wind turbines will be very useful when the peak demand loads are very, very high. So with this graphs, we have 7 months of data, and many people ask this question that why Tamil Nadu has not been brought first. This was the precise reason that we never had the hardcore data, whatever we was banking on the mesoscale data. So we thought that to give them the confidence to the developers, we can defer slightly by 4 or 5 months. And once we have the hardcore data, then it will be easy for the developers to participate with confidence to mitigate the risk of underperformance. And similarly, we have also done pre-feasibility evacuation studies. Of course, CTU and PGCIL authorities are available as the panel members. They will give you more insight during the course of discussions. But here, instead of 315 MVA transformers, we are planning to 2 into 250 MVA transformers. And here we will be going to 11 kilometers on the coast, wherein, Avri Kulam is the substation where we will be injecting it. And from there, the TENJETCO and CTU together has to take a call whether we will inject finally to the Tuticorin 765 by 400 kV substation or to the Pogulur HVDC substation. So the basic information has been done, and I've been also told this morning that they have gone in advance for tenderings and all for making the grid infrastructure ready, because there is always an element of fear in the mindset of developers that they will build the turbines, but these will not be ready. So we hope that this will be ready first and the turbines will be coming, so there won't be any mismatch which has happened in Germany or Netherlands some time back. And to also give you a confidence, KPMG is here. UK has also supported KPMG in helping us in doing on all these 14 zones, the rapid environmental impact studies, which we have already completed with the technical support of NIWE, wherein we have taken the 91 samples in the entire 14 zones, and we have measured the water quality, the salinity, the nickel, cadmium, all the precious materials, even the microorganisms like phytoplankton, zooplanktons have also been captured, because that is the basic requirement of the carbon trust, not carbon trust, CRZ regulations from Ministry of Environment and Forest Climate Change. And we will also be doing once the project is over, so that the reference values which we have measured should also come back once the project is over, so that there is no effect on the turbidity, the salinity, or any microorganisms by building up this offshore project. So this is what has been done, so that once the tenders are finalized, it should not happen that environmental impact assessment studies are not being given. So to overcome that, we have also completed its study also. And moving forward, I also want to inform you the last slide, because already Stewart has given me a warning that when you start speaking, you take 1 hour. So at 10 minutes, I will put you a lock to you. So I think I am, sir, within time now, because that is why I was speaking very fast, so that he should not catch hold of my neck. And the last slide, sir, is that on zone 1, again in a fast track mode, people think that government bodies are always delayed, but ministry is always after us. In 4 months, we have given the geophysical studies. But unfortunately, the vessels have gone 2 times in this area. First time in May, and we did this green color, 10% job, but then there was a safety issues because the wind speeds were 20 knots, which was more than 10 to 12 meters, and the waviness of the waves were not allowing us to capture the data, more efficiently. And there was also safety issues. And because of the, bad weather conditions, we were forced to board the vessel, demobilize the vessel. We tried again in September, and again this story repeated. So now we have planned that at the end of December, once this northeast monsoons in southern part of the country is over, either by end of December or January, we will again go back and try to complete this by February mid, and by March, before this tender, we will be ready with the geophysical and 3 sample geotechnical studies up to a depth of 60 meters, which is bare minimum required to install 15 megawatt plus offshore wind turbines. So this is the latest work which National Institute of Wind Energy has carried out. And last, I want to also give a message that also there is an element of fear in the developers that the clearance protocol from the central ministries and the state departments will take a lot of time. I assure you from NIWE that it will be given to you within 3 to 4 months, once the project is being awarded to a responsive bidder, backed up by ministry, so that clearances will not be a bottleneck for your development of offshore wind. So with this, Mr. Stewart, I am in time. So thank you very much for giving me a patience listening. Thank you.
Now we're going to get into the panel discussion, and David, I'm going to come to you first, but before I ask you your first question, do you want to give the audience a little bit of background about yourself and the background of OWC for those that might not know?
Yeah, sure, I'll be quite quick. Hi, so David, I look at the new markets around the world for OWC. We're part of a wider group called ABL. ABL are present in Mumbai. I've been working in the oil and gas side for well over 15 years. Our role is advisory to governments, to developers, to financial institutions for transactions and to auctions. We've recently done some work with the government of the Philippines, looking at their potential support pricing for offshore wind, and we're working with the industry in Canada to coordinate their responses to possible auction mechanisms for the Canadian leasing round in Nova Scotia. The rest of it is engineering services right across how to develop and construct a wind farm. My own background, 30 odd years, I'll just leave it there, civil engineering and a mix of oil and gas, wave and tidal energy, subsea power interconnectors and offshore wind as a developer. I've helped construct the last of the UK around 1 wind farms some time ago, and obviously as a consultant.
Thanks very much for that. So the first question then, how important is having clear volume targets and bankability for the making a market come firm and concrete, and those signals that we get into the market?
Yeah, so I'll try and draw a few comparisons to see where we go. And I've already been changing some of my thoughts as Dr. Katyal's presentation came forward there, because it sort of changes your understanding a little bit, knowing some of the information that's actually being produced. So first question, I suppose, is where is the money coming from? Because that then sets the scene for the diligence levels that have to be provided right throughout the project. So if India wants to attract international finance, as well as what you're doing now, there will be expectations around how things are structured to bring that money in at reasonable levels. So if it's Indian banks, fantastic. They can work more closely with you. If it's international finance, they'll look to international finance standards. And a lot of this isn't dark arts. A lot of it is just really good fundamental project structuring and project management. So the challenges for India are well known, and the potential bidders are trying to address these. Things like the fundamentals of the strength and knowledge and experience of the project sponsor, the developer body themselves. And obviously, offshore wind is new to India. There'll be some partnering arrangements being put in place to bring in experienced developers to work alongside Indian developers who bring their own experience from the oil and gas sector and onshore renewable sectors. The teams below them, the project delivery teams, the same thing again. You need people with solid experience in how to coordinate and bring a project through into delivery mode and then construction mode. So proven technology is the next question. So, there's a strong desire for made in India, understandably so. The question is, in the early projects, how much do you want made in India? If you're talking about a 15 megawatt turbine, that's likely to be internationally. Then the question associated with that is, can you produce the demand required to get the attention of those people who are currently producing 15 megawatt plus turbines? If you want a new made in India turbine by one of your turbine manufacturers, how long does it take to bring that turbine through the testing, validation, and certification stage? And what size would they be willing to take on? So 15 plus is the kind of standard, but that then has the knock-on consequence into supply chain. And again, can you get the attention of the supply chain that is capable of installing that size or greater of turbines? That then brings in the volume question. So making a start, the 500 megawatt VGF, that's a good start. It's a great start. The question is that of sufficient scale to kickstart an industry in India and get the attention of the Indian manufacturers, fabricators, vessel makers, and the attention of the international community? So my gut instinct is no for the international community. It needs to be bigger, and it needs to be more volume, more certainty, and the VGF probably needs to continue for more gigawatts and for a longer period. We haven't done the numbers crunching ourselves, but so that's, you asked for personal opinions, I'm giving you a personal opinion. I could go on, but I think appropriate risk allocation and such is the next stage. But I'll stop there and
Sure.
let anybody else come in.
Yeah, so thanks for that. I just wanted to follow up with just one thing. I mean, you talk about the volume and the market volume. So has offshore changed that much? I mean, if you think back to when Taiwan was an emerging market, those initial volumes, the signals weren't much stronger, and yet everyone queued up. So can you explain the difference between what happened there and here?
Yeah, the Taiwanese market looked really attractive financially. Fundamental is that. The India market looks more challenging financially for those early projects. So every country around the world looks at the prices now and kind of anticipates that's where they should start. Everybody will start higher if you're starting with a new market that's, in this case, more remote from established markets. You have to generate the supply chain and the capabilities. Then the prices start coming down. So in the UK, we started off with different mechanisms. We've adapted them over time. Prices have changed. We've got the CFD mechanism now, which is working, but even that's under review. And it's as simple as that. The Taiwanese market was much more financially attractive at that time.
Thanks for that. Now I'd like to come to the perennial question for any offshore wind market, the challenge of the grid. And I know that most people would know the central transmission unit for utility for India, but maybe a little bit about your background before we get into the big question about is the grid going to be ready and what are the challenges? How is India going to avoid the classic grid challenge?
Good afternoon. I'm Anil Kumar Meena, working as General Manager in Central Transmission Utility. Building and development of a transmission network is never an easy task because there are a number of issues that includes ROW. Then there is a further challenge once you even encompass with the ROW, then there is a requirement of mix of generation. For the smooth and reliable operation of the grid, you need to have the appropriate mix of the generation, and then there are a number of different things. So in that way, at least for the Indian power system, at least we have done the justice till now. So in that way that there is no generation has been bottled up till now because of availability of the ISTS network. And in that, with one arrangement or the other arrangement, we had been able to evacuate that generation and able to supply that to the intended or targeted consumers. So in that way, and also as per the Government of India policies and the guidelines, we are planning the transmission network and infrastructure in advance before the generation requirement so that we can match the requirement of the transmission for these generation projects.
And sorry, just to back over it, so for the developers that are looking for some certainty around timelines, because I mean, grid challenges always tend to move to the right traditionally in market. I mean, so that certainty is there that the grid will be ready in time for the developers?
Yes, regarding the offshore wind development, what we have done is as per the potential declared by the MNRE, the Ministry, Government of India, we had identified the transmission system in advance itself. And in the initial phase, for the 5 gigawatt of the offshore wind projects, each in Tamil Nadu and the Gujarat has been identified. And out of that, for the time being, 500 megawatt, the transmission project for 500 megawatt is awarded to Power Grid Corporation of India Limited through regulated tariff mechanism. And we have made this provision in such a way that both the pooling stations at the coast of Gujarat as an onshore pooling station and at the coast of Tamil Nadu, they can be expanded up to 5 gigawatt. So every station will take care of 5 gigawatt of offshore energy, which will be generated at the coast of Gujarat as well as at the coast of Tamil Nadu. For further and these system without any generation commitment or any application to CTU has been awarded to give a signal that the transmission is already been awarded, taken an advance leap, so that the fear of that matching transmission will not come with the offshore wind generation. That should not be there in the mind of the wind developers, offshore wind developers. And subsequently also, after this tender, once we get the positive signals, then the subsequent phases of the transmission will be identified. And in general, our approval process of new transmission system is roughly about 6 to 8 months. Within 8 months, whatever is the new transmission need, we are getting approval of it. Now, onshore onwards transmission implementation do not take normally 24 to 30 months. So 30 months is the average or the maximum time which we are taking at the moment. But the challenge here is the subsea cable, the establishment of the offshore pulling station, and then the array cables. So that these, regarding these, we don't have the Indian manufacturer or supplier also. So while we were estimating the transmission system for the offshore wind, that point of time also we faced all these challenges. We were not able to get the broad cost estimates also, because how do we go about it? So at one point of time, we took this decision that let us give it to a government organization through a regulated tariff mechanism who can invite international tenders, and the first project can be taken up in that way. So that is how we have gone ahead. And for the future requirement, in the phases, we will go ahead with the planning and identification of the transmission system. The implementation route may differ. It may not be through the RTM route. It may be through the tariff-based competitive bidding route itself. But what we assure is that the transmission will not be a bottleneck for development of the offshore wind projects. Just only since this is a first project of its nature. So we are also going on step by step. That's it.
Yeah, thanks. And I'd like to, if we have time at the end, come back to the cable challenges around the world. Bibhu, a little bit about your background in Fugro, and then I'd like to actually speak about the other big perennial challenge that we have in offshore wind, the vessels challenge. And as the turbines get larger and larger, the fleet becomes smaller and smaller because we have fewer vessels with the right crane capacity to be able to do offshore wind. So a little bit about your background and then perhaps how you see the vessels picture in India.
Thank you. I'm Bibhu Nayak, Country Director for Fugro. Fugro has been involved in currently more than 60% of offshore projects globally, offshore wind projects. And India, where for the last 27 years, myself with 30 years experience in offshore construction industry, mostly oil and gas. What I could see in India, we have a matured offshore construction market. We have been building platforms, jackets for the last 50 years now. And for last 25 years, it is all being manufacturing, the fabrication and installation is done from India. So yes, it is a slightly specialized offshore construction, but if you think three phases where the vessels are required, one is before installation and during installation and after installation maintenance. Before installation, as Dr. Katyal said, we have taken care all the vessel requirement is being fulfilled from India to carry out the survey, geotechnical and other studies. Yes, we have bit of, challenge in getting the construction vessels to install bigger platforms. But we have companies in India who owns large capacity up to 3,000 ton crane barges. And they have installing up to 2,500 ton platform jackets. So it's not a big deal. They may be busy, but once they know there is work in India, they can be secured. And post-installation platform like maintenance, India has been doing for the last 70 years. So I don't think it's a problem. It is just reorienting the current workforce, current vessels, modifying the vessels to do the work for wind farm, which is basically essential offshore platform. Now with more than, I would say, 250 offshore platforms been existing for so many decades and they have been maintained. I really don't think, if you can think and orient, and India being a matured shipping as well as offshore industry in place, this can be managed very well. The owners of these fleets has to be interested and orienting themselves once the project takes off. I don't think is a big challenge. I think we're there.
Okay, that's really interesting. And so the cabotage laws here in India, is that going to require Indian staff vessels or Indian flag vessels?
Yeah, India has a cabotage. If you have a vessel of similar capacity, you have to have Indian vessels. But if you bring in a you need a crane barge of say 2,000 tons, and we do not have any Indian owner having that vessel, then cabotage doesn't apply.
Thank you for that. And so, actually, Floris, now to you and LAUTEC, maybe a little bit about, we're going to speak about project management and how the project management of an offshore wind technology is vastly different, or maybe vastly similar to other forms of generations. But maybe a little bit about yourself and LAUTEC before we get into that question.
Yes, so my name is Floris. I've been with LAUTEC since almost its inception. We're supporting projects globally, primarily offshore wind projects, through consultancy and IT solutions geared towards offshore wind projects. With respect to the question, I think in some regards, these projects are projects, right? So they need the management that you would, and the diligence that you would have on any other project. I think without stating the obvious, the big difference is that these are offshore. And it just means that things get complicated and the risk profiles of the projects change. So you cannot simply get into a car and drive down to site and see what's going on, what's happening, is the contractor doing their job properly, etc. And the other aspect is the cost aspect. So things offshore cost vastly more than things onshore. Going out to have a look at what your contractor does easily costs you 20,000 euros. So it just means that in everything you do, you need to consider these costs and these risks and these challenges and make sure that you're ultra prepared, but also make sure that you have the systems in place to check and control and understand that what the contractors are doing offshore, as you can't see it from the office. So we're, for instance, offering IT systems that help monitor and track vessels, that help monitor and track what these contractors are doing offshore on a daily basis from hour to hour, ensuring that they do the jobs properly, ensuring that they're not sitting outside on a vessel that costs you $500,000 a day, looking around and watching the sunset. So, you know, having these systems in place and ensuring that you can track and monitor is essential.
Sure. And so what are some of the tools? Is that through IT solutions, or can you explain a little bit more about that?
Yeah, so for instance, we are offering a couple of systems, a daily progress reporting system that allows the vessel to report on an hourly basis what they're doing, so you can ensure that they're progressing as planned. We offer modeling systems that allow you to model your offshore campaigns, making sure you select the right vessel for the right job, making sure you plan your works in the right season, but also quality inspection tools to ensure that whatever you bring offshore can actually be installed and is in the right state to be installed on time.
Thanks. Dr. Katyal, I'll come back to you now in terms of you presented the several models for the funding of offshore wind and just when you look at these, do you think that these are actually going to be enough to accelerate the uptake of the offshore wind market here in India? The different models, the B and C models?
See, actually, the Ministry of New and Renewable Energy has come up with a strategy paper in September, which clearly specifies that there will be 3 models. One is on Model A, which is they are supporting with viability gap funding for both 500 megawatt for Gujarat and 500 megawatt for Tamil Nadu. And there, you know, already the tender has been out, as I already mentioned. Tamil Nadu tenders will be very shortly announced. And apart from that, as per the trajectory, we went for Model B 4 gigawatt tender also, because in Model B, everything will be given left to the developers to build, to do the measurements and then go for the development, and so that they have a choice where they want to go in the identified zones. And for that also, in the 23-24, we wanted to go for 4.5 gigawatt, which we have already done tendering. And in the next financial year also, once we get the lessons learned from the first 4 gigawatt seabed and also from 500, we need to only replicate for the another 3.5 gigawatt for the next financial year, which also will be done because that's not a big deal. Only thing we are waiting that what will be the lessons learned from these 2 tenders, so that we are trying to incorporate in our future protocol. And then, it will be a replicating game year-on-year basis. Our trajectory of 37 gigawatt, we can do every year-on-year basis the similar tender. So we are on track, and we will be doing that as per the committed strategy plan issued by the ministry. And in model C, we have left to all the developers that anywhere across the Gulf of Kambat or Gulf of Mannar or anywhere other in the 7,600 kilometers, they are free to come up with any kind of project which they feel that they can do their own measurements, the wind speeds, the met ocean, and they can come up with their own projects, and they will be free to do. So that is to fast track the growth of offshore, and rather I would say fostering the growth of offshore wind in the country.
Thanks. Then maybe to David, you've just heard that. From your perspective, is that are these the right drivers? Is this the right accelerators you need to see in market?
Yeah, the three different models. So Model A is Cusp, and the VGF aspect to that sets the scene, and there is data being collected. It's heading towards a Netherlands-type model of de-risking the site for the developers. I think everybody will now be chasing you, Dr. Katyal, for the data that is there and that you will publish. Because the sooner that is published, the better, because especially the geophys information, geotech information you have, because that then de-risks the project for that area. And it also helps the other areas because it provides some level of correlation that they can take into other areas. So, changing anything on Model A now, kind of pointless, I think. It needs to go on. There may be details in the contractual mechanism and performance bonds and guarantees and such, but that's another matter. Model C, that's for the future. That's after the projects have been built with the support mechanisms. That is going to be quite a number of years down the line before I would imagine anyone's brave enough to take that model. But it leaves the door open if anyone is brave enough. Model B, I think the one comment I would make on Model B is extending the site security. They have site security during survey period. I think if you look around the world at different models, having that site security at an early stage and extended with performance requirements from that stage on, it's very difficult for a developer to spend money without site security. So I would look at that again and see if there's any way of modifying the time period associated with that to allow developers to make the best use of the survey campaigns they've done, and then do some check-ins on how you maintain progress and performance further on. But other than that, the models sit together in a continuum appropriate for now, aside from my comment about wishing to extend the funding into future gigawatts. But even that can be reduced over time, and I think that's the essential point that's happened everywhere else. Government support heavily at the start, and then gradually reduce the funding that's available, and that mechanism works. So perhaps have a look at that as well.
Thanks. Then, Floris, I might jump to you in terms of any advice from a project managing perspective for the tendering agencies.
Yeah, so I think David made some really good points, and I was actually going to add to that. I think from that perspective, what they need to keep in mind is the risk that these companies are taking in developing a tender. It costs a lot of money to develop a tender and to submit a bid. If there isn't enough security after award, or even if there's too much competition, then these developers will take a global perspective and look at India as one of many countries where they could develop these projects. So in instances where they feel there's too much risk involved, then they'll probably not come and bid on these projects. So I think, as David said, to have site security up until survey is crazy, because you're investing tens of millions of euros in doing the survey and developing the project up to that point, and then to risk to lose it all. I don't think there's a lot of appetite in the market for doing it that way. So I think from their perspective, they need to consider the risk and the decisions that these companies are taking on whether or not they should bid. And losing out everything is a big risk to them.
Thanks for that. Anil, I just wanted to come back to the cabling issues and the cabling challenges and how India, cable shortages is a challenge all around the world. How's India going to be placed when it comes to this very specific technical challenge?
As far as we are aware, regarding the subsea cable, which is a very specialized technology, there are very few suppliers worldwide. So ultimately, if the energy cost which have to come down, which we are supplying to the consumer, that is only it can be done if it can be manufactured in the domestic market itself. So at the moment it is not there, but then in my opinion, in the initial phase, they can have some kind of JV or tie-up with the international suppliers for immediate requirement. And in the long term, as our target is going up to more than 60 gigawatt of the offshore wind projects. So to that, ultimately it has to come to the domestic market also. This is also in the perspective of the grid operation also, because as per our 500 gigawatt target by year 2030, we will be adding quite a large amount of solar generation, and we are retiring the conventional generation projects also. Thereby, we are losing some of the advantages and benefits the conventional generation is having. So there is no way we can meet this round-the-clock power supply other than the offshore wind supply, wind power, which will be there 24/7, maybe with small variation or lesser quantum. So, the domestic market has to develop, maybe in the phases, to bring down the energy cost as well as the infrastructure and project cost also. This includes maybe the wind turbine projects also, cable manufacturing and all other infrastructure works which we are expecting for the offshore wind development.